Welcome to my project about the brain. I'm Ashton Henderson. Okay, let's get started. Okay, so this is what most people think about the brain, and it's actually correct. It controls most, if not all, of the things we do outside of what just goes on in every single little cell and what organ can do by itself. But usually an organ relies on stimuli from the brain for it to even start doing what it can do by itself. Okay, so when you look at the brain, you usually think of this area and its frontal lobe, which does the planning, thinking, judging, feeling, speech, that stuff, and even deciding and movement. And then people also may think about the parietal lobe, which deals with touch, spatial awareness, sound, just all kind of the upper back area of the brain. And then, of course, there's the temporal lobe, which deals with emotion, memory, sound, and stuff like that. And then occipital lobe, which deals with visual processing, vision, recognition, a lot of stuff that deals with sight. But also there are other parts of the brain too. So let's go to this part. So we will start with the older brain. The brain's oldest and innermost region is the brainstem. This is where the spinal cord starts to swell slightly and becomes these things, which I'll get to. Okay, so where it starts to slightly swell, this part is known as the medulla. This controls the heartbeat and breathing, so you don't have to think, okay, heartbeat, heartbeat. You don't have to consciously do it. It does it for you. And you don't have to think about breathing. You can control your breathing, like some people have learned how to control their heartbeat, like people who do professional skeet shooting and stuff. They've learned how to slow their heart rate down so that they can actually shoot correctly and the heart rate doesn't affect it. But this controls it to where when you don't want to think about it, it keeps it going for you, keeps you alive. And then there is the pons, which is above the medulla, is not this. It's this part. The part on top of the medulla is. Now the pons is, it coordinates the movements and it controls sleep, which is very important to how we function. Heck, I can't go without sleep. And then these two things make up the brainstem. Okay. Now, what goes through the brainstem from the spinal cord is the reticular formation. It even goes up to the thalamus. Okay. This filters incoming stimuli, relays important information to other parts of the brain, and it controls arousal. So it does all the nitty-gritty stuff and gets stuff from the spinal cord up to all the higher function places. Okay, and then there's the thalamus. Okay, the thalamus it sits on top of the brainstem, of course. It acts as the brain sensory control center, which it receives all sensory information except smell. and sends it to the higher brain regions. So this kind of is the control outlet. Okay, it sends it to places like this area, and even we'll get to it later, the cerebral cortex, which I've also already mentioned. Okay, so after the thalamus, there is something called the limbic system that kind of surrounds it. And the limbic system also control it does stuff you wouldn't think. It's not usually thought of when you think of like digestive system, nervous system, and stuff, but it's a system. Okay, so first you're starting with the hypothalamus, which is it directs several maintenance activities and is linked to emotion and reward. So say a dog is given a treat every time a rat is given a treat every single time it runs across a very painful electric wire, which and it really hurts it, but it gets food after, so it goes through it. That's where that's what hypothalamus is, why it would even want that reward. And it also helps govern the endocrine system via the pituitary gland. Now, the pituitary gland is the master gland of the endocrine system, meaning it tells all the other glands in the endocrine system, which basically produces all the hormones the body needs. It produces hormones that then tell other glands to produce another type of hormone, which might go to another gland again, or it'll cause some reaction in the body that needs to happen. And then there is the amygdala. Okay, the amygdala is linked to emotions, especially fear and anger. People who have had lesions or something wrong with this have actually been considered to have no fear. There's even this woman who had a lesion or something in the amygdala and was called the woman without fear. Even when threatened with a gun pointed at her head, she was not afraid. She did not react. Her heart rate did not go up. And then there's a hippocampus, which goes kind of like the amygdala. It kind of goes all around here, and it kind of connects to the amygdala and other amygdala too. It's all kind of connects, but the hippocampus is it helps process explicit memories for storage. So the loss of it has resulted in the inability to form new memories of new facts and events. Some people have had to lose it through surgery because they had seizures in it. And when they did, they could remember everything before the surgery. But after, it was like every single day was the day after they had the surgery, because they didn't remember anything between the surgery and that time, because they didn't have the hippocampus to process all of it. Okay, and then right kind of above in this area of the brain is called the corpus callosum. This is made of axon fibers connecting the two cerebral hemispheres, which I will show you right now. Okay, so then there's of course the cerebral cortex, which is what everyone mainly thinks of when they are thinking of the brain. It is actually divided into two hemispheres, each controlling the other side of the body with the mechanical movements, like the right brain controls the left arm and the left brain controls the right arm. But also it has other functions, like one side has speech processing while the other has speech output. And uh, there have also been split surgeries from the corpus callosum being removed, and and many studies have been done on these people who've had to have this. They usually have it because a seizure may start in one half of the brain and then it crosses the corpus callosum to the other side of the brain and it makes it all worse. Well, in this case, it would just stop and just one side of the body would be affected by this, while the other side can function. Well, they have done extensive studies and been able to figure out what side of the brain does what, like I mentioned before, one side does speech processing, or like you can see something but you can't say what it is, because you could see something on one side but you can't say what it is because the speech processing part is on the other side, but you may be able to sing what it is or write what it is on the others. Write what it is. It's crazy. Okay. And then there is, of course, you can see the limbic system from there and the older brain and everything. But then there's this thing called the cerebellum. The cerebellum is what coordinates voluntary movement and balance, and supports learning and memories of such. So basically, that saying in athletics, muscle memory, that's where it all happens. So that's why you have to practice something over and over again, so your cerebellum actually can memorize it, and you could do it without even thinking the next time. Thinking like specifically to do something. And then lastly, there is the spinal cord, which is the pathway for neural fibers traveling to and from the brain, and it controls simple reflexes. So, say you're playing dodgeball, or a tennis ball is hit right at you 100 miles per hour. Well, the brain cannot process stuff fast enough, cannot go up to your brain, think, hey, a ball's coming at me, then process, hey, I need to move, I need to duck or move, and then do it. It's very complicated that way. So there's the spinal cord, which actually takes care of that for you. You see the ball, immediately spinal cord takes care of it and you duck. Unless you really have never done that before. Or when you feel a sharp pain, you flinch, and that's from the spinal cord. Okay, so, but then there's this other part of the inside the cerebral cortex called the motor and somatosensory cortex. Well, it's actually two things. Okay, the motor cortex is of course like toe. It controls like toes, ankles, knee, hip, all that fun stuff, and it does it in a specific order. Because right beside it is the somatosensory cortex, which is where you feel everything. So, like you could feel stuff on your toes. Well, right next to where you feel, where the brain processes feeling in the toes, is also where it can control the toes. And so that goes on and so forth. And that's where this is where all of the sports and everything, like you feel the racket in your hand, you feel something cold in your hand, but you have to decide, I have to keep holding it, instead of that spinal cord making you suddenly drop that really cold thing. You have to, this processes it to where you could keep holding it and just get through the terrible icy pain of holding something really, really cold like ice for like 10 minutes. Okay, so that's where all that comes in play. And so that is it. If I can get back here. Well, sorry, I'm trying to get to the credits here. Hold on. Hold on. Okay, so this really doesn't like it. Actually, in my YouTube profile, in the YouTube comments, I will have the specifics of where I got all the information and everything, but all of the pictures except for the background picture come from the psychology book written by David G. Myers and C. Nathan Dewell, and everything, and that's where all the pictures and all my information came from. So thank you for watching.